Hi guys, so what we're going to learn today is we're going to learn how to solve a polynomial, and we're going to use division to help us do this. So the first thing I want to point out is just remember that we can solve any quadratic, and a quadratic is x squared, by either factoring or using the quadratic formula. And with higher polynomials, this is not so easy, so it's going to take us a lot of steps to be able to do this. So I want to just walk through this. And I have it listed out, and then you guys can always pause and stop and go backwards as much as you need. But the first step is to find a root, and a root is seriously just an x-intercept with your calculator, and then we're going to use some division and we're going to make this go down. So the first thing that we want to do is we want to go into our calculator and we want to plug this in. So I'm going to go over here to my calculator, and I already have this typed in, but you're going to go to y equals, you're going to type this equation in, making sure that you're doing really carefully positive, negative signs and everything. And then what you're going to do is you're going to go to your table and you're going to try to find an x-intercept. So if I go to my table, remember x-intercepts are where y equals 0. So we're looking for where y is equal to 0 for these problems. So if I zoom in here, I can see that there's a y equals 0 there and there's a y equals 0 there. So what that means is that I have x-intercepts for this problem at -1, 0 and at 2, 0. And both of those are going to come into play. So since y is 0 right here, those are our two x-intercepts. Okay, I'm going to pull this back over here. All right, so here's what we do. Let's just take one of those x-intercepts. So I'm going to start with 2, 0. And what you have to do is you have to create a factor from that root. So what that means is that I take this number and I switch the sign. So this now becomes an x minus 2. So this is the factor that gives me the solution. And then what we're going to do is we're going to divide this polynomial by this factor. Okay, so in step number 2 over here, I'm technically taking this original polynomial and I am dividing by the x minus 2. So let's remember how to do this. The first thing we do is we put what we're dividing by in the boxes on the side over here. So this becomes x minus 2. And then I put my highest degree in this box right here. So this becomes x to the 4th. And then you're just doing the puzzle to figure out how this works. So what does this box need to be so that when I multiply it by x, I get x to the 4th? Well, this has to be x cubed. Okay, and then I can figure out this box by doing -2 times x cubed is -2x cubed. And then remember that our diagonals have our like terms. So this diagonal and this diagonal are going to be our cubes, and I want my final answer to have -1x cubed. I'm already at -2, so I need to add a +1 to it to make that balance out and become a -1. And then we do our puzzle. So let's see, if this is x, this needs to be an x squared, so that when I multiply, I get x cubed. And then this would be a -2x cubed when I multiply those two boxes together. And then remember diagonals. So this diagonal and this diagonal are going to be our x squareds. So I need those to be -5x squareds. I'm at -2, so I need this to be -3, so that when I add those together, I get -5. And then I do the puzzle, so this would have to be a -3x up top here. And then if I multiply -3x times -2, this is a +6x. And then diagonals again. So these are going to be my x's. And I want my final answer to have 3 x's. I'm at +6 at the moment, so I need to subtract 3. So this becomes a -3x. So then the top of my box would be -3, and then -3 times -2 becomes +6. And then that was a 6 and a 6, so I don't have a remainder. The first thing you want to check is that these things definitely divide evenly. You shouldn't be getting remainders, okay? So what you've done at this point is you've now factored this original polynomial to be x minus 2 times, and then our answer was this x cubed plus x squared minus 3x minus 3. Now, if I were to set this equal to 0, which is what we do whenever we solve, I can easily solve for this x minus 2 at the moment, but you guys are not sure how to solve this because it's a cubic. So I need to do this one more time, and I need to do division until this gets down to being a quadratic. So I did have one other x-intercept. Above, we said that there was another x-intercept at -1, 0. So what you do is you make your factor, so it's x, and then you switch the sign. So since this is a -1, I'm going to add 1. And then what I'm going to do is I'm going to divide this cubic function by this factor right here. Okay, so we're going to go to step 4, and we're going to do that division. So I'm doing x cubed plus x squared minus 3x minus 3 divided by x plus 1. Okay, so what you're dividing by goes on the side here. And then remember your highest degree goes in this top box. So this is x cubed. And then this top box has to be an x squared so that when I do x squared times x, I get x cubed. And then this has to be an x squared. And then we do diagonals. So this and this are going to be my x squared, and I need 1x squared. So I already have 1x squared. So what we have to do is I just have to add a 0x squared, so that if I do 1 plus 0, it stays at 1. And then what's weird here is I do want this to continue. So I need there to be a 0 up here. So when I do 0 times x, it becomes 0. And then I also need an extra x, so that when you do x times x, you get x squared. And then when I do this, 0x times 1, this is going to be 0x. Okay, let's do diagonals again. So we've got, these are going to be my x terms, and I want my equation to have negative 3x's. So at the moment I'm at 0, so this diagonal has to be a negative 3x. And then my top box up here has to be a negative 3, so that when I do negative 3 times x, I get negative 3x, and then this has to be a negative 3, which matches nicely because this was a negative 3, so that matches. Okay, so now what we have done is we have factored that original equation a little bit further. So we've now taken this cubic function and said that it can be written as x plus 1 times what we got as our final answer right here, which is x squared plus 0x minus 3. So if we bring all that down here, we've got x minus 2, x plus 1, and then x squared plus 0x minus 3, all of those equal 0. So now we're down to a quadratic, so we can take this and we can solve by factoring or any steps that we know how. So what we're going to do is we're going to take each of these factors and we're going to set them equal to 0. So I'm going to take that first factor, x minus 2, set it equal to 0, and solve. So if I add 2 to both sides, you get x equals 2. So that's one of my solutions. Okay, then I'm going to do the same thing. If I take x plus 1 and set it equal to 0, subtract 1, you get x is negative 1 is another one of your solutions. So we have 2 x-intercepts that we already knew were solutions because we found those above at 2 and 1. So now what we're going to do is we're going to take this final quadratic equation here and we're going to solve it. So I'm going to take x squared, I'm going to ignore the 0 because it doesn't matter, minus 3 equals 0. And what I'm going to do is I'm going to solve. Now this one is easy, you don't have to factor. I'm just going to start by adding 3. So you got x squared equals 3, and then in order to get rid of the squared right here, you do a square root. Just remember when you do that square root, we put the plus or minus in front. So on this side, your square root and your squared cancel, so you get x equals the plus or minus the square root of 3, and then those are your other answers. So now all you do whenever you're listing out your solutions over here is you write them as points. So remember our points are x, y, and our y values were equal to 0 for all of these. So for this first value, I'm going to have a root at 2 comma 0, which is just an x-intercept. And I'm going to have another x-intercept at negative 1 comma 0. And then I'm going to take this one and break it into 2 parts because you have a positive square root of 3 and a negative square root of 3. So you have positive square root of 3 comma 0, and you have negative square root of 3 comma 0. And then those are all of your solutions to this polynomial. So you guys are officially done. So let's just go through steps one more time. Plug this equation in your calculator, find a root or an x-intercept, change it into a factor, do division, and then continue to do division until you get your answer to be a quadratic. And then once you have a quadratic, you're going to take all of these things, set them equal to 0, and solve. Okay, so we're going to do one more example. Okay, so this one, let's start with our calculator. So we take our calculators over here, go to y equals, clear anything out, and let's type this in. So x raised to the third plus 3x squared, 3x squared plus x minus 5. Okay, so then we're going to go second table, and what we're looking for is where there's a y value equal to 0. So I see 1 right here. So we've got 1 comma 0, and since this is a degree 3, I only need to do division once to get it down to a degree 2. So I really only need 1. So 1 comma 0 is going to be our root. Okay, so remember what you do is you take that sign and you switch it to get it to be a factor. So this is going to be an x minus 1. All right, and then we're going to take the polynomial and we're divide. So I'm going to divide this by x minus 1. So remember the x minus 1 goes here, whatever you're dividing by goes on the left side. And then my highest degree, this x cubed, goes in this box. And then again, it's just working through the pattern. So at the moment we're doing x cubed plus 3x squared plus x minus 5 divided by x minus 1. So we can try to get it down to a quadratic. Okay, so let's see. This has to be an x squared. So when I do x times x squared, I get x cubed. This has to be a negative x squared. And then let's do our diagonals. So this plus this should add to be negative 3x squared. So I'm at a negative 1 at the moment. If I want it to be a positive 3, that means I need to add 4 to it. So it's going to be a 4x squared because 4 minus 1 becomes 3. And then let's see, this box needs to be a 4x. So that when I do 4x times x, I get 4x squared. This would be a negative 4x. And then diagonals again. So these are my x's. And I need my x's to be 1. I'm currently at negative 4, so that means this needs to be a 5x, because when I do 5 minus 4, I get to 1. And then this box needs to be a 5, and then when I do 5 times negative 1, this is negative 5. Again, this should divide nicely. So this is a negative 5, and this is a negative 5. We're good. So what we did is we took this original function, and we factored it first to be x minus 1, and then this answer up here. So we're taking this original one and factoring into x minus 1, and then the top, x squared plus 4x plus 5 equals 0. And now we're down to a quadratic, so we stop and we just solve. Remember what this means is we take each of these factors and we set them equal to 0 and solve. So this first one is easy. You take x minus 1 equals 0, you add 1 to both sides, you get x equals 1 as one of your solutions. The other one is a little bit harder because it doesn't factor. Because if the only things that multiply to 5 are 5 and 1, and then there's no way that 5 and 1 can add to a positive 4. So what that means is you have to do the quadratic formula for this guy. So we've talked about this a little bit, but x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then let's just remember what these things are. So your a is 1, your b is 4, and your c is 5 for this one. And then all you do is you just plug it in. So we've got x equals negative b, so negative 4, plus or minus the square root of 4 squared minus 4 times 1 times 5, all divided by 2 times 1. Okay, and then we simplify. So let's see, we've got negative 4 plus or minus the square root. If I do 4 squared right here, this becomes 16. And then if I do negative 4 times 1 times 5, negative 4 times 1 is negative 4, times 5 is negative 20. So minus 20 over 2 times 1, which is 2. Okay, so this becomes negative 4 plus or minus the square root, and then I do 16 minus 20, which is negative 4 over 2. Now we have to take this a little bit further. We do know that we can do the square root of negative 4 because it's the square root of negative 1 times 4. And this, square root of negative 1 is I, and the square root of 4 is 2. So this just becomes 2i. So we can write this as negative 4 plus or minus 2i over 2, and then you're able to divide the 2 into both of the parts of your numerator. So if I do negative 4 divided by 2, this becomes negative 2, plus or minus, and then 2 divided by 2 right here becomes I. So you've got x is equal to this are going to be my last 2 solutions. Okay, so then let's write those out. Let's write them as points. So the first one, remember we're writing these as x comma y, where y is equal to 0. So if you have an x is 1, one of your solutions is 1 comma 0. And then these ones are a little weird because you have a plus or minus. You technically have a negative 2 plus I and a negative 2 minus I. So one of my solutions is going to be negative 2 plus I comma 0 and negative 2 minus I comma 0. And then the way we know we're totally done with this problem is that we have a degree 3 to begin with. So this was a degree 3 polynomial, and I have 3 solutions written down, so I know that I am finished. Okay, so if we go back to the one up here, this was a degree 4 polynomial because the highest degree was 4, and then we got 4 answers. So we knew that we were finished. So this has a name, and this is called the fundamental theorem of algebra. And all it says is a polynomial function of degree n, meaning anything, has exactly, or has n solutions for the equation f of x equals 0. So all that means is that the degree of your polynomial tells you how many solutions you should have. So for example, if I have like x to the 5th minus 1 equals 0, my degree right here is 5. That means this should have 5 solutions whenever we're all finished. Okay, and then if you have like x to the 4th plus 2x minus 1 equals 0. This is a degree 4, so it should have 4 solutions whenever you're totally done. So that's all this fundamental theorem of algebra is. Your degree tells you solutions, then you just want to check that whenever you're done. Okay, last thing, you guys can pause and write these down, but these are just the steps you should be going through that we went through above. So the first thing you do is you find an x-intercept with your calculator, type the function into y1, pull up the table and find the value, x value where y equals 0. Turn the x-intercept into a factor by switching the signs. Divide your polynomial by the factor in step 2. And then you repeat this, the steps 1, 2, and 3, until your polynomial that you end with, that you get as an answer, is a degree 2. It can't have anything bigger than that because it's harder to solve. And then once you get to a quadratic function after doing all of the division, you're going to use factoring, or you're going to use the quadratic formula to solve the last 2 solutions. And then you're going to write all of your solutions down, including the ones you found on your calculator. Now, a lot of you guys struggled with this simplifying square roots whenever you get to the quadratic formula. So I do just want to go through like how you would simplify the square root of negative 20 real quick. So what you do is you look for perfect squares. Remember, perfect squares are like 1, 4 because 1 times 1 is 1, 2 times 2 is 4, 9 because 3 times 3, 16 because 4 times 4, 25, etc. And what you're going to do is you're going to take these numbers and you're going to divide them into 20 and see which ones divide nicely. Well, I know that 4 divides nicely into 20, so I can break this into this negative 1 times 4 times 5, because 4 times 5 gives me 20, times negative 1 is negative 20. So this is still equivalent, but I know I can do the square root of these because the square root of 4 is a nice number. I can't do the square root of 5, so that gets stuck. And then we do just have to remember that the square root of negative 1 is I. The square root of 4 is 2. So what that means is when I do the square root of negative 1 here, it comes out of the square root as an I. And when I do the square root of 4 right there, it comes out as a 2. So you get a 2I out front. And then I can't do the square root of 5, so this stays square root of 5. And then that's how you simplify it. So that's hopefully going to help you guys simplify those quadratic formulas when you get there. I don't know that many of them on this homework assignment are that hard, but just make sure you know how to simplify your square roots, that you guys are showing all your work, doing your division, and then just following these steps to solve your polynomial. You guys are now going to do the 832 part 1 homework. And as always, if you need anything or are confused, please reach out, ask for help. I'm here and I am ready to answer your questions. I hope you guys are all doing good and that you're having a great day. Bye, guys.